Okay, so I'm gonna do one question here, on this book, and I'm just gonna put it up so it's a little easier to do. It's gonna deal with 1.7 and 1.8 homework, so I'm just going to draw this out. Of the force vector is 82.3 newtons. The x component of this vector is along the plus axis of the magnitude of 74.6 newtons. Y. So I'm just gonna write the homework out so it's easier to read. So the two questions are: find the direction of the vector relative to the x-axis, which is just denoting the degrees, and the second one is of the vector along the y-axis. Give me 1 second. My desk is a complete mess, so if you hear anything fall, it's due to my desk being absolutely shot. So, let me retype this. Thank goodness I'm a fast typer. So, we're given that the magnitude of the force vector is 82.3 newtons. The x component of this vector is along the x-axis. So what is the magnitude again? So in the magnitude, a magnitude is just the hypotenuse. So it's going to be 82.3. And I draw arbitrarily, but we're told that the x-axis is slightly smaller, so like 10 newtons smaller, or whatever. I can't do the math. It's actually 6.3 newtons smaller. So I could do the math, but I didn't. But anyways, if the magnitude is equal to the hypotenuse in the same, or if the magnitude is equal to the x component or the y component, that means that it's not a triangle, it's just a line. So like if they say like 80 newtons north, that's the same, the magnitude is 80 newtons, and the y component is also 80 newtons. So if it's the same thing, or if it's just a straight line, then it's the same thing. But here we know it's not, because the magnitude is not equal to the x component. The magnitude is 82.3 newtons, and the x-axis is 74.6 newtons. So what are we given here? We're given the x-axis, or the x component, not the x-axis, and we're given the magnitude. Guess what we could apply here? So remember, the magnitude is always just a Pythagorean theorem. 82.3 squared is equal to 74.6 squared plus b squared. And you could say y squared here, but I'll just put b. It's the same thing, b or y. So then we could just solve this by doing 82.3 minus 74.6 squared, and then square root it. That's what b is equal to. You can simplify this if you want to do it algebraically in your head, but just use a calculator, please. 82. I'm not even going to try to simplify it. Let me just pull out a calculator, which I probably should have done. My desk is really messy. So, 82.3 squared minus 74.6 squared. And that's going to be equal to 34.76. But note what this question asks. So, the first one is find the component of the vector along the y-axis. So that's what we solve for. So, like the person I am, I solved the second part of the question first. So I solved for the y first. So now let's redraw the triangle. And we have 74.6 and 34.76 and 82.3. So we solved the entire triangle. But it's asking for the angle here, or the direction of the vector relative to the x-axis. So since this is above the x-axis, it would be this many degrees above the x-axis, meaning let's solve for this. So there's multiple ways we could solve it using inverse trig functions. So if anyone knows what an inverse trig function is, it basically reverses what tangent does. So remember, the tangent of an angle gives you the opposite over adjacent. Here that would be opposites, 34.76 divided by 74.6. So inverse tan both sides, which crosses out the tangent, equals inverse tan of this ratio right here, which I'll just pull down, 34.76 divided by 74.6. And we get 24.98 degrees. You can round sig figs, so that would be 25.0 degrees, logically. And so the answer is 25.0 degrees above the x-axis for the first part, and it's 34.76 newtons tall. That's all it is.